Okay, let's dive into this. We all know about the explosive rise of AI, right? But honestly, the truly fascinating story isn't just the models themselves, it's the birth of an entirely new discipline, AI engineering. Today, we're drawing from Chip Huyen's comprehensive guide on building applications with foundation models. We're going to explore how teams are taking these massive pre-built models and turning them into practical, everyday tools. So, welcome to this explainer, where we're going to break down exactly how this revolution is being built, literally piece by piece.
To map out this landscape, we're going to follow 5 steps today. First, the AI scale explosion. Second, inside language models. Third, enter foundation models. Fourth, real-world AI applications. And finally, planning your AI strategy.
All right, let's kick things off with Section 1, the AI scale explosion, and the unprecedented velocity of AI tools.
You know, AI engineering has rapidly emerged as one of the fastest-growing engineering disciplines in history. And why is that? Well, it's because of a major shift: models as a service. Instead of needing millions of dollars to build an AI model from scratch, developers can now just access incredibly powerful models via a simple API call. Just take a look at the GitHub star growth for open-source AI tools. The lines for AutoGPT and LangChain, they are nearly vertical. They're vastly outpacing massive mainstays of the tech world, like the web framework React or even Bitcoin. The developer world is moving toward AI at lightning speed.
So the crucial point here is scale. These tools are growing because the models powering them have achieved unprecedented scale. To put that into perspective, when OpenAI's first GPT model came out back in 2018, it had 117 million parameters, which are basically the variables the model learns during training. At the time, that was considered huge. Today, well, modern language models regularly boast upwards of 100 billion parameters. It's that sheer, mind-bending capacity to learn that unlocks what we're actually building today.
Moving on to Section 2, inside language models. We're going to understand the under-the-hood mechanics.
To truly engineer AI, we really have to start at the fundamental processing unit, and that is the token. A token strikes the perfect engineering balance, you see. It keeps the model's vocabulary size efficient by breaking words down into manageable chunks, while still retaining vastly more semantic meaning than just single individual characters.
Now, what's really interesting here is how GPT-4 tokenizes a phrase like, "I can't wait to build awesome AI applications." Notice the word can't right there. It actually splits it into 2 distinct colored tokens, can and apostrophe T. By chunking text this way, the model can efficiently process both common words and totally made-up words simply by understanding their core structural components.
Okay, so once text is tokenized, the model has to predict what comes next. And there are 2 main ways to do this. Down at the bottom, we have masked language models. Think of this kind of like filling in the blank. It uses the context from both before and after the missing token to figure out what fits best. That's great for things like sentiment analysis. But at the top, we have autoregressive language models. These predict the next token based exclusively on the preceding tokens. It's basically a continuous open-ended completion machine. And this autoregressive approach? It's the primary engine behind the massive generative text explosion we are seeing everywhere right now.
But that begs the question, how on earth do we get enough data to train models with 100 billion parameters? Well, we had to shift from supervised learning to self-supervised learning. Supervised learning requires expensive human labeling. Manually labeling a million images might cost $50,000, and honestly, a lot of developer tears. It is a massive human bottleneck. Self-supervised learning, on the other hand, bypasses that human bottleneck entirely by inferring labels directly from raw data. Because the internet is absolutely packed with raw text, the text itself provides the context and the answer. It acts as the ultimate, infinitely scalable solution. Which brings us to Section 3, enter foundation models. We are moving beyond just text. Let's move to and see how this builds, because human beings perceive the real world through vision, sound, and touch, right? So AI had to evolve to match that. By merging text tokens with visual tokens, standard language models are elevated into true multimodal foundation models. Instead of a model only reading a description of a puppy, it can take the text, "This is a," combine it with a picture of a puppy, and predict the next token accurately based on both data types. This general-purpose capability is exactly what transforms a standard LLM into a comprehensive foundation model.
And because these foundation models are so broadly capable right out of the box, AI engineering today is mostly about adapting them for specific tasks. This saves you from the massive expense of building from scratch. We generally do this in 3 main ways. First, prompt engineering, which is carefully crafting the instructions. Second, retrieval-augmented generation, or RAG for short, which connects the model to an external database, like your company's documents, to give it much better context. And third, fine-tuning, which means slightly training the model further on a highly specific dataset just to lock in a desired behavior or tone.
All right, let's pivot to Section 4, Real-World AI Applications, taking this from hype to practical utility. Moving from hype to utility, let's take a look at over 200 popular open-source AI applications currently on GitHub. Two categories absolutely dominate the landscape here. Coding tools make up over 30%, and conversational bots make up over 26%. Combined, they represent over 56% of the popular open-source application landscape. So developers are heavily prioritizing AI to help them write better code and to create intelligent bots that can talk to users, act as companions, or serve as customer support co-pilots.
And when looking specifically at coding, the efficiency gains are real, but they are a bit nuanced. This McKinsey data proves that AI cuts time spent on code documentation significantly. We're talking nearly a 50% time reduction. It also helps massively with basic code generation and refactoring. However, notice that far right column. For highly complex tasks, generative AI provides less than a 10% boost. So it is a truly powerful assistant for the tedious heavy lifting, but human expertise remains entirely essential for the hardest problems.
We actually see a very similar division of labor over at Duolingo. Look at stage 1 there, curriculum design. The green bar showing human work is massive, because curriculum design requires deep, nuanced human expertise. But then jump down to stage 4, lesson personalization. Here, the purple AI bar completely dominates. AI handles the incredible heavy lifting of personalizing content for literally millions of unique learners. That is a task humans simply couldn't scale to do manually.
Now, when we shift to the enterprise landscape, risk mitigation really drives the strategy. Notice how companies heavily prioritize lower-risk, internal-facing applications. Over 60% are willing to deploy text summarization or internal knowledge management. And why? Because if the AI hallucinates, well, it's just an internal mistake. Contrast that with the far right. Less than 40% are deploying external-facing chatbots. Enterprises want to build their AI engineering muscles privately, behind closed doors, before risking their customer-facing brand reputation.
Finally, Section 5, Planning Your AI Strategy. We're going to look at a framework for implementation.
So how do you strategically plan and actually integrate these models into your workflow? The first step is brutally assessing your actual risk level, because that dictates your development requirements. Ask yourself, are you adopting AI because it's an existential threat? If competitors using AI will make you obsolete, this is your highest priority. Or is it a profit and productivity opportunity? Say, using AI for better ad copy or faster customer service? Or is it simply R&D exploration? Defining this why determines exactly how much you invest and whether you should buy an off-the-shelf solution or build it yourself.
Next up, you need to define the user experience. Will your AI be reactive or proactive? Reactive AI, like a chatbot, responds quickly to a direct user request. Since users are actively asking for help, they are generally way more forgiving of slight delays or imperfections. Proactive AI, on the other hand, is opportunistic. Think of a traffic alert popping up on your map. It's pre-computed, so latency isn't a huge issue, but it requires a dramatically higher quality bar. Because the user didn't ask for it, if a proactive AI feature is wrong, it isn't just a glitch, it's incredibly annoying.
Finally, how do you safely scale this whole shebang? Microsoft's Crawl, Walk, Run framework is an absolutely excellent human-in-the-loop strategy to empower your organization. In the crawl phase, human involvement is mandatory. AI generates suggestions, but a real human must approve them. In the walk phase, you take a step forward, allowing the AI to interact directly, but only with internal employees. It's like a safe sandbox. Then, once you've ironed out the issues and really built trust, you hit the run phase, allowing increased automation and direct external user interaction.
As we wrap up this explainer, I want to leave you with a provocative question for your own strategic roadmap. Is AI critical to your product, or is it just complementary? If your application simply cannot function without it, like, say, facial recognition software, your AI engineering requirements for accuracy are absolute. But if it's just a complementary feature, like an autocomplete suggestion in an email app, users will be a lot more accepting of occasional mistakes. Defining the true role of AI in your business is the foundation upon which all your engineering efforts will be built. Thank you so much for joining me to explore this fascinating world of AI engineering.